So just like in chapter 1, where we started with linear equations and moved into linear inequalities, now same thing in chapter 2. We started with solving linear equations or graphing linear equations, and now we're going to move into linear inequalities in these two variables. So in 1.5, we graph solutions like this. And when you graphed x is less than 3, you only needed the x-axis. And then you'd put on your 3, and you'd say that the solutions are anything less than 3. And they were only in one variable. Now what we need to do is change from one variable into two variables. And so we're going to move into this Cartesian plane, or the rectangular coordinate system. So the first thing you're going to do is graph a line in two variables. So something like y equals x plus 3. Since this is in y equals mx plus b, you're going to graph your slope as 1 over 1, and you're going to graph that your y-intercept is the point 0, 3. So we're going to start with our point 0, 3, and we're going to graph our slope. Up 1, right 1, up 1, right 1, up 1, right 1. I don't have a ruler, so I'm also going to go down 1, left 1, and then all of these points are going to be on my line, and then I can connect them. So if we were just doing linear equations, the solution to this would be every point on the line. And that would make y equal x plus 3. So every point on this line satisfies this equation and makes it true. We're going to move on to inequality. So there's going to be more than the points on this line that's going to make your inequality true. But no matter what, you're going to start with this line. This line is called a boundary line. It splits. Sorry, I can't talk and write at the same time. It's called your boundary line. It divides your coordinate grid into two parts. I'm not going to say halves because it's not going to be perfectly in half, although keep in mind that what we draw here is only a part of the solution. This graph could go up to infinity, right to infinity, down to negative infinity, left to negative infinity. So really what we're doing is dividing it into these two parts, or half planes. And what's going to happen is the points in one half of the plane, or one part of the plane, are going to make your inequality true. So first step, no matter what, is to draw this boundary line. So here's your steps for graphing a linear inequality or solving a linear inequality. Step 1 is drawing your boundary line. But we need another part to this. Your boundary line either will or will not make your equation true. If you had less than or greater than, your equation can't be equal to. In other words, for this one, if it was just less than, the points that are on this line wouldn't make the equation true because they'd make it equal. So only if it's equal to do you draw a solid line, like what we did up here. And if it's not equal to, the way that we show that the points on the line are not solutions to the problem is that we draw a dashed or a dotted line. Now, once you have your boundary line drawn, your next step is to decide which half is going to be shaded. The way that you determine this is you look at the equation. Now, this is the cheater way. So number 1 is the cheater way. If it shows as less than, if you think of your boundary line here, so let's say we have that boundary line from above. If the answer is less than, this is saying that the y values will come out less than x plus 3. So the solution for less than will always be below. It'll be down here. So you shade below the line. If the sign is greater than or equal to, you're going to shade above. Now, I'm not the biggest fan of number 1. I think what's better is to use a test point. So you're going to test, does a point above the boundary line make the inequality true, or does the point below the boundary line make the inequality true? You're going to shade the region containing the test point if it made the equation true. You're going to shade the region that does not include the test point if it made the equation false. Now, this is going to seem really weird right now. Don't worry too much. I'm going to go through this example. So we're going to do this example. All of these, you'll notice, are the equation y equals x plus 3. If I ignore the inequality sign, they're all y equals x plus 3. So they're all going to have a y-intercept of 3. They're all going to have a slope of up 1, right 1. every single one of these. Y-intercept of 3, slope of up 1, right 1. The difference is going to be, so I'm just going to put some points on here. The difference is going to be whether you draw the boundary line, so this is step 1, whether you draw your boundary line as solid or dashed. If your equation is equal to, you're going to draw a solid line. Now again, I need some more points because I don't have a ruler I can use. And so there we go. So this is going to be a solid boundary line. If it is not equal to, then the points on the line will not make the equation true because they would make it equal, and there's no equal sign there. So what we would do is instead of a solid line, you would take your ruler again, and you can just do a dashed line, showing that the points on this line will not make the equation true. So try the next two. Pause the video maybe, draw them in with your ruler, and then unpause when you're ready. So this one's equal to, so we're going to do our solid line. And this one is not equal to, so we're going to draw our dashed line. So it's still a boundary, but the points on it will not make my inequality true. Okay, now I have to decide whether I shade above or below my boundary line. So step number 1 is to look at it and go, okay, if it's greater than, you shade above. If it's less than, you shade below. Done. Super simple. But does it make sense of why you did that? So for example, this one was greater than, so you'd be shading above. Well, what does that mean? It means that any point on this side of the boundary line will make the equation true. So if I pick a point like this one here, -3, 3. If I were to test -3, 3, it will make my equation true. So if I put in y is 3, is that or greater than or equal to -3 plus 3? Is 3 greater than or equal to 0? Yes, this point made the equation true. So you're shading the side that is true. If I were to test a point like 0, 0, which is on this side, it shouldn't make my equation true. So is 0 greater than or equal to 0 plus 3? 0 is not greater than or equal to 3, so this is false. So this point did not make the equation true, so we shaded the other side. This point did make the equation true, so we shaded that side. So you can kind of go through and just be like, if you're positive about your signs, because keep in mind these aren't going to be all written like this. Some of them are going to be in standard form, and you got to think about flipping the sign. So the safest way to do it is a combination. See if you're right. You think it's above, now test a point there. If it comes out true, you're good. If it came out false, it should have been the other side. So usually what people do is they test 0, 0. So if I was to test 0, 0, is 0 greater than 0 plus 3? Is 0 greater than 3 is false. So this point did not make the equation true. So again, a point on this side will. And you can either test a point on that side, or you could look at it and be like, hey, greater than, it should be above, depending upon what you want to do. Now these have an inequality sign switched. So this time when I test 0, 0, what's going to happen? Well, is 0 less than or equal to 0 plus 3? Is 0 less than or equal to 3? Yes. This time 0, 0 did work. So I'm going to shade this side. And did that work with my, my shortcut? And because it's less than, I shaded below, so I'm all good. And then it should be the same for this one, because that point 0, 0 is still less than. 0 is less than 3, so this point here worked. It is less than, it is below, and I'm going to shade this side. And that's all there is to these. So you're drawing a boundary line, and then you're checking to see whether the answer is above or below the boundary line. You can do that using the cheater thing. If it's greater than, shade above. If it's less, shade below. Or you can do it by testing a point. And I think a combination of the two is perfect. So let's try another one. So first off, I'm going to graph y is greater than or equal to 2x plus 3. To graph, I'm going to graph my boundary line. And when you graph your boundary line, just ignore the inequality. So you're graphing y equals 2x plus 1. So I'm going to have a slope of 2, and I'm going to have a y-intercept of 1. So I'm going to go 0, 1 with a slope of up to right 1, up to right 1, or down to left 1, down to left 1, down to left 1. Then, because it is equal to, I'm going to draw a solid boundary line because it is greater than or equal to. So I'm going to connect my dots with a nice solid line and put my arrows on the end. Now, to solve the inequality, because again, not just the points on the line are going to make this true, it's one part of the boundary is going to make this inequality true. So I'm checking, is it below or is it above? The way this is written, it's looking like above. So I'm guessing this is the side that I'm going to shade. So to make sure, test a point over here. Test a point like -2, 0. So I'm going to test -2, 0. Does it make it true? Is 0 greater than or equal to 2 times -2 plus 1? Is 0 greater than or equal to -4 plus 1 is -3? Yeah, it's true. So this point satisfied the equation. If I were to pick something on this side, like 0, 0, if I were to test 0, 0, which is on the other side, is 0 greater than or equal to 2 times 0 plus 1? Is 0 greater than or equal to 1? It's false. So none of the points on this side will make the equation true. Only the points on this side will make the equation true. All right, moving on. What happens when they start out in standard form? Well, you have two options. Option number 1 is graph using x-intercepts and y-intercepts. Option number 2 is put it into y equals mx plus b. When you do this, you can either keep the inequality sign or you can make it an equal sign if you're afraid you're going to mess up with it. So I'm going to keep it there. I'm going to minus 4x from each side. I'm going to get -3y is less than -4x minus 12. Now I'm going to divide every term by -3. When you divide by a negative number, make sure you flip your inequality sign. So this would be y is greater than +4/3 x plus 4. Now, if you're just doing this for a boundary line, keep this as an equal sign if you're afraid you might mess up your inequality, because no matter what, my slope is 4/3 and my y-intercept is 4. So no matter what happened with this inequality sign, this is true. So I'm going to have a point at 0, 4. And I'm going to have a slope of up 4 and right 3. So I could go up and right, but I go off my grid. So instead, I'm going to go down and left. So 2 negative directions still makes a positive slope. Then I go down 1, 2, 3, 4, left 1, 2, 3. I'm going to do that again. 1, 2, 3, 4, left 1, 2, 3. Now when I connect my lines or connect my dots, I'm going to do this with a dotted line, because it is not equal to. So I'm going to go like that, and I'm going to just draw this nice dashed line. Now I'm trying to decide which side of the boundary line to shade. Never, ever, ever plug into or test into this equation, because you might have messed up. Okay, so according to this, I'm guessing it's above. So maybe I'm going to test a point like, I don't know, -3, 5. But when I test it, I'm going to test into this equation. So I'm going to test -3, 5. So 4 times -3 minus 3 times 5, is that less than -12? Well, 4 times -3 is -12. Minus 15, is that less than -12? So that's -27. Is that less than -12? Yes. This point made the equation true. Some people always test 0, 0 because it's a nice easy test point to test. If I were to test 0, 0, again, always into the original equation, I get 0 minus 0 is 0. Is that less than -12? No, that's false. So this point did not make the equation true. This point did make the equation true. So you're going to shade the point that makes it true. Last one is this graph. Now, technically, if this was chapter 1, you would just go like this. Now we have to figure out how to take a one-dimensional answer and draw it two-dimensionally. So the first thing we're going to do is draw our boundary line. So again, when you're drawing the boundary, you just kind of ignore the inequality and think, I'm graphing x equals 3. A graph of x equals 3 is going to go through 3, and it has an undefined slope. And so it's going to be vertical through x equals 3. Now, don't do what I just did. Make sure that you look at the fact that this is less than. So since it's less than, it's going to be dotted or dashed. So I'm going to go like that. And now just like you would graph to the left because it's less, yes, we're going to just do over here. But technically, you can test a point. So if I test a point like when x is 0, I can't test a y. I go is, so I'm going to test 0, 0. I can only plug in for the x, so is 0 less than 3? Yes. If I was to test something like 6, 0, and I was plugging in x is 6, is 6 less than 3? No, it's false. So we shade this whole side. So all of these points are going to satisfy the equation in 2 variables, which is very similar to 1 variable. All right, so that's 2.4. I know we jumped again, so we did 2.3.1, learned how to graph a line. This is practicing graphing those lines, and then in 2.3 part 2, which is next, we're going to find the equations of lines.